Good morning, this is Dr. Turner for Integrated Math 3. Today we're covering 3.4, which is factoring polynomials. This is another lesson that we're going to be splitting into two parts. So this first half, we're just looking at sort of the easier examples, and we'll talk about some different techniques for doing that. So factoring is basically going backwards from multiplying polynomials. We're trying to see if we can break it up into chunks. And one of the ways that we can do that is sort of simply just by guessing. So let's say I had something like x squared plus 10x plus 21, for instance. If I want to factor, I'm trying to see if I can break it up into pieces. So you're sort of doing reverse FOIL. Remember in FOIL, we did first, outside, inside, and last. So the first terms are going to have to be factors of x squared. And so because we're looking at an easy example here, the only thing that I can go there would be x times x. The last terms, that gives me a constant. So I'm looking for some numbers here that I can put that multiply to get 21. So this could be 1 and 21, or it could be 21 and 1. It could be 3 and 7, or it could be 7 and 3. Now with FOIL, right, we already figured out the first terms, we already figured out the last terms, so it's the outside inside that we need to check. I already know if I put, let's say 1 and 21 here, I already know when I multiply it, I'm going to get x squared and then I'm going to get 21. What I'm checking for is that the other terms add up to my b, add up to 10 here. So if I check that, 1 times x is x, x times 21 is 21x. If I add those together, I get 22x, so that's too high. So that tells me 1 and 21 are not the factors that go there. Okay, well, let's look at different factors of 21, 3 and 7, for instance. Now, if I put those there and check, 3 times x is 3x, 7 times x is 7x, and when I combine like terms, yes, those add up to 10x. So this would be my answer. So that's sort of the plug and chug method. You're just writing in there and you're just trying to figure out, making sure that those middle terms add up to 10. Well, that could be a little tedious, especially if your C term is something that has a lot of factors. Let's say I put 36 here. I'd have 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6, right? So there's a lot of different combinations that I would have to use to check. So what we usually do for these simple polynomials, and right now we're looking at polynomials with a leading coefficient of 1. So for all of these, we're going to have a 1 here. Makes it a little easier, and then in the second video, we'll talk about what happens when we don't have a 1 there. So let's look at an example. X squared plus 8x plus 15, for instance. Okay. This method is what's known as the magic X. Also known as a product sum puzzle. So what we are looking for is what we're going to do rather. On top for right now, we're going to put whatever our C value is on top. Later, it's going to be A times C, but for now, since all of our A terms are 1, it's just C. And then in the bottom, we're going to put our B term. So 15 goes on top. 8 goes on the bottom. And so what this product, and again, it's called product sum, is asking for is I'm looking for what numbers multiply to get 15, but add up to 8. And so some of you guys can do that pretty quick in your head. Looking at the factors of 15, I have 1 and 15. I have 3 and 5. The factors that multiply to get 15 but add up to 8 would be, of course, 3 and 5. So that means that this factored is x plus 3 times x plus 5. and that's factoring. So I'm going to have a few more examples here. X squared minus 12x plus 20. So I write my product sum puzzle. I'm looking for the numbers that multiply to get 20 that add up to negative 12. So because my C term is positive and because my B term is negative, that tells me that both of these factors have to have a minus sign, right? Because a negative plus a negative is a negative, but a negative times a negative is a positive. So I can write out all the factors of 20, and these would be negatives. Negative 1 and negative 20, negative 2 and negative 10, negative 4 and negative 5. And you don't have to write them all out. Some of you can do this in your head, but once you get to the correct answer, you can stop. Right? So looking here, minus 12 and minus 10. If I add those, I get negative 12. If I multiply them, I get a positive 20. Therefore, this factored is x minus 2 times x minus 10. Let's do another example. X squared. Let's do plus 4x, and we will do minus 60, for instance. So I'm looking for two numbers that multiply to get negative 60, but add up to 4. So here now, because my C term is negative, that tells me that one factor has to be positive, one factor has to be negative. In the same process, I can go through, I can look at all the factors of 60, remembering that because I have a negative, it could be either or, right? It could be positive or negative. So 1 in 60, that's going to be too high. Skip down a couple here. 3 in 20, 5 in 12. 6 and 10. So 6 and 10 work, right? Because I can take a difference there to get 4. So 10 and 6. And because I want a positive 4, that means I need my 6 to be negative. 10 times negative 6 is negative 60. And 10 times negative 6 is a positive 4. There are some special cases, and we'll talk about special cases for polynomials in another lesson. So let's say I had something like x squared minus 81. Well, here I don't have a b term, right? There's no b there. So that means the b is 0, and my c still stays the same. I'm looking for two numbers that multiply to get negative 81, but add up to 0. So for them to add up to 0, they have to be the same, just with an opposite sign. And so when you see 81, you should be thinking these numbers end up being positive 9 and negative 9. So therefore, this is x plus 9 times x minus 9. On these types of examples, and we'll talk about this formula in more detail in a later section, this is what's known as a difference of squares. So if you see that b is a perfect square, you're taking the square root of that number, and then you're writing x plus that number, x minus that number. So for instance, if I had x squared minus 36, I can still use the x, but this ends up being x plus 6 times x minus 6, because it's a difference of squares, because 36 is a perfect square. Also, you could have an example where you have a c term that's 0. So x squared plus 8x. If there's no c term here, you can still use the x if you want. I'm looking for two numbers that multiply to get 0, but add up to 8. Well, if they're multiplying to get 0, then one of the terms has to be 0. And 0 plus 8 is 8. Therefore, you have x plus 0 times x plus 8, or just x times x plus 8. We've talked about factoring before. If I saw a problem like this where I don't have a c term, I'm not going to do the x, although I can. I'm just simply going to take an x out of each term and move it to the front, leaving me with x plus 8. That's all for now, guys. We will talk about this in a little more detail in the second section. Have a good day, and I'll talk to you soon.